All right, this next section is going to be about running Spark jobs on a real cluster. And there are many ways of doing that. Obviously, you can't just spark up the Spark IDE, no pun intended, and run that on a cluster because you're probably not going to have access to a UI and all that good stuff. So we need a way of actually running these scripts from a command line and in a way that they can actually be distributed using a cluster manager of some sort, such as Spark's built-in cluster manager or Hadoop's Yarn. So let's talk about that packaging process first, and how do I package and deploy my Scala Spark driver scripts to a cluster? Well, we did that in the previous lecture. We had an example of actually running our movie similarity script using the Spark submit command. And let's talk about that in a little bit more depth and what was going on there. So in order to prepare a script for being run with Spark submit as opposed to within the IDE when you're developing and debugging, you have to make sure, first of all, that there aren't any hard-coded paths in that script to your local file system. And that's something we're kind of guilty of throughout this course so far. We've been putting in these relative paths to the Scala project that we're actually running from within the Scala IDE. But in the real world, you want to make sure that your data is coming from some distributed, reliable file system that is accessible to every node on your cluster. That might be an HDFS file system on a Hadoop cluster, or Amazon S3, or something else. But you want to make sure that your scripts are not assuming that your data resides somewhere locally on your hard drive, because that will not scale. Then you just have to package up that script into a jar file somehow. The Scala IDE makes that easy because we can just select the package and say export to jar. And once we have that jar file, we just need to copy that wherever it needs to be, where we're going to actually end up running it, either locally at first to test it out or on your actual cluster on your master node, and use the Spark submit command to actually execute that driver script. Now, what's special about Spark Submit versus running in the IDE? Well, a few things. First of all, Spark Submit wraps the entire process of kicking off your script and maintaining it, so it can actually integrate with a cluster manager and figure out, okay, how do I distribute the script out to the entire cluster? How do I integrate with the cluster manager to actually make sure that my job is actually distributed and reliable? How do I make sure my RDDs are really R&D, reliable and distributed, right? It also has some mechanisms in it for managing dependencies. So there's a -- jars option, for example, where you can specify paths to any jar files for other Scala packages or Java packages that your code might depend on that isn't part of the core Scala or Spark packages themselves. So for example, you might have an add-on library for integrating Spark with some other system like Kafka or Flume or something like that. You might need a series of jar files to actually enable that functionality in your script, and you can use the -- jars option to actually say, okay, here's where you can find that jar file. Make sure that's added to my dependencies for this script. You can also tell it to automatically distribute a set of files alongside your script. So if you use the -- files option, if you have some small data file, that might be a reasonable way to make sure that it's available to every node on your cluster. So let's go and try it out again. We did do this before, but let's go through it a little bit more slowly and using a different script and refresh ourselves on how Spark Submit works. So let's go ahead and look at using Spark Submit again as opposed to running from the IDE. Another thing that's good about Spark Submit is that it's something you can run from a command line, right? So you can actually kick off this script periodically using a cron job on an actual Linux cluster or Nagios, whatever you use to actually schedule jobs in a real production system. So you can't really do that with an IDE, right, in a graphical user interface. You need to be able to actually execute these commands from a command line prompt, from an OS level thing. The other good thing, too, is that by packaging things into a jar file that's just Java bytecode, we can run this script on any operating system that supports Java. So, I can develop on Windows like I'm doing here, upload that jar file to a Linux cluster, and use Spark Submit on that Linux cluster, and it will work just fine. Okay, so that's kind of cool, too. So, as before, let's right-click on our package here and select Export. And what we're going to do is package up our popular movie script as something that we can run from Spark Submit. So I want to select a Java jar file. And again, don't get confused. Even though we're writing Scala code, ultimately it's Java in the end. So we're going to do a Java jar file. And we're going to export all of our source code. And let's save this inside the folder that we're working at for this course, C Spark Scala, inside the Spark Scala course file, and let's call it popularmovies.jar. Now this is actually identical to the moviesims.jar file that we generated earlier because this particular Scala package contains all of the objects that we've created so far. So we're going to pass in as an argument to Spark Submit which object I actually want to execute. And later on, we'll talk about using another tool called SBT that will let you skip that step even and only package up what you need. But for now, let's do this. And we'll hit finish. So now I should have a popularmovies.jar file inside that file. So let's spark up a command prompt here. And I will cd to see Spark Scala, which is my course folder. And you can see I have my Spark Scala course folder inside of that. Go into there and take a look. We do have a popularmovies.jar file. Now to execute that, I'm just going to do this from the command line. And again, I could actually copy this popularmovies.jar file to the master node of a cluster, run Spark Submit, and it would actually run on the cluster. But for now, let's do it on our local desktop. Spark-submit --class com.sundogsoftware.spark.popularmovies, and the name of the jar file itself, popularmovies.jar. And again, if I had any dependencies, I could use the jars option to specify those. If I had files that I had to distribute alongside it, I could use files for that. But let's just see how this works. And it actually executed and gave me all the results. So there you have it. And as before, the most popular movie is movie ID 50, which is Star Wars. Cool. If we scroll up, well, I don't have enough buffer to really see it, but Spark Submit did all the work of actually splitting that job up across the cores of my computer. So it actually did distribute that as best as it could by creating up to 4 different processes on the 4 cores of my CPU. And again, if you were to run that on a real cluster that was configured properly under Hadoop or Hadoop Yarn, or even using Scala's built-in cluster manager, Spark Submit could have just under the hood distributed that to the entire cluster. There would be nothing else you would have to do to make that happen. So there you have it, using Spark Submit. So let's go on to a more advanced way of actually packaging up your Scala Spark scripts called SBT. We'll do that next.